If Earth escaped the sun, how long would humanity survive? Imagine that the world is turning normally one night. Cities are glowing. People can still see the moon above them. But something has changed. Earth is no longer orbiting the sun. There is no explosion. The ground does not split open. No one feels a sudden jolt. Earth keeps rotating as if nothing has happened, while the planet quietly begins moving along a new path into the dark. This is not a prediction about the near future. It is a thought experiment, a way to see how deeply life on Earth depends on sunlight, and what might still survive if our planet became a rogue world between the stars. Tonight, we will follow the timeline from the first minutes of darkness to the distant possibility of cities built beneath the frozen surface. And the final question may not be how cold Earth would become. It may be whether humans could still call a sunless planet home. To understand the scenario, we first have to understand an orbit. Earth is not riding on a track. It is moving forward at roughly 30 kilometers per second, while the sun's gravity continually pulls it inward. The balance between forward motion and inward pull makes Earth fall around the sun, instead of falling straight into it. If another star passed close enough, its gravity could disturb that balance. In some models, Earth could be thrown into a new, much wider orbit, or even ejected from the solar system as a rogue planet. But escaping the sun would not mean that Earth stopped moving. The planet would keep its momentum. It would continue spinning. Stars would still fill the sky. The moon might even travel with us, if the disturbance carried the Earth-Moon system away together. The first change might be something we do not notice at all. The sunlight would not vanish instantly. Light takes about 8 minutes and 20 seconds to travel from the sun to Earth. In our imaginary scenario, we would continue to see the old sun for a little more than 8 minutes after its light stopped reaching us. During that short delay, instruments on Earth would still register sunlight and solar energy normally. Then the horizon would change. Not like an ordinary cloudy night, but like a world whose star has been removed from the sky. The moon would not shine by itself. It only reflects sunlight, so a full moon would become a dark circle hanging above the planet. Cities would not go dark immediately. Hydroelectric plants, gas turbines, nuclear reactors, batteries, and stored fuel could continue to provide electricity for a while. Greenhouses could remain lit. Spacecraft would still operate according to their own systems. What would disappear at once is the largest energy source in the entire ecosystem. Plants use light to turn water and carbon dioxide into food. That process is photosynthesis. Without light, every plant would not die in a single night, but growth would stop quickly. Some plants could use stored energy for a while. Seeds and spores could wait in darkness much longer. But every garden would slowly become a food supply with an expiration date. Herbivores would be affected first. Then the shock would move through predators, agriculture, trade, and finally every human community that depends on food and clean water. The cold would not arrive like a switch being flipped. Land and oceans store an enormous amount of heat. The atmosphere would still move, and heat from Earth's interior would still rise through the crust. At first, the oceans would act like a vast blanket, slowing the fall in temperature. But Earth's energy balance would be broken immediately. Normally, the surface and atmosphere absorb energy from the sun and release heat back into space. Once no new sunlight arrived, Earth would radiate more energy than it received. The global average temperature would continue to fall. The first night could still bring rain in some regions. Some places might feel strangely ordinary for a while. But as time passed, water on the surface would begin to freeze from the top down. The oceans would not become solid all at once. A surface layer of ice would act as insulation. Water below could remain liquid, and geothermal heat could keep scattered regions warm. That is why a sunless Earth might still contain hidden habitats for life. Not on the frozen mountains, but in deep oceans, beneath thick ice, and around hydrothermal vents on the seafloor. Ecosystems around hydrothermal vents do not depend directly on sunlight. Some microbes use chemical energy from materials rising out of Earth's interior, passing energy to other organisms in the surrounding water. On a rogue planet, these small ecosystems could become a new kind of light for life. And what about the moon? If the moon stayed gravitationally bound to Earth, its pull would continue to create tides. The sun also contributes to Earth's tides, but the moon is the stronger influence. So the loss of sunlight would not make the ocean stop moving overnight. Coasts would still rise and fall, but the weather patterns powered by sunlight would slowly change. Winds would weaken in some regions. Storms would follow new patterns. Ice would spread away from the poles. If Earth were thrown out violently, the moon could move into a different orbit, or escape as well. The answer would depend on the direction and speed of the gravitational encounter. There is no single picture that fits every model. That distinction matters. A thought experiment is not a forecast. Any estimate about how many days until the surface freezes, or how many years until the oceans change, depends on the atmosphere, cloud cover, ocean depth, geothermal heat, and Earth's new orbit. Physics gives us a more reliable conclusion. Far from the sun, surface water becomes harder to keep liquid. With no nearby stars supplying energy, the surface gradually cools. Humanity would have to redesign the idea of a city. Cities that once opened toward the sky might move underground. Buildings would no longer be designed mainly for sunlight and rain. They would be designed to hold heat, filter air, recycle water, and waste as little energy as possible. Power could come from nuclear reactors, geothermal systems, or technologies that do not yet exist at the scale we would need. Food-growing chambers would become the heart of every settlement. Red and blue grow lights would replace the sun. Crops would be chosen not only for taste, but for calories, durability, and the amount of water they required. Every drop of water would pass through filters again and again. Vapor from breathing, moisture from showers, and condensation on the walls would become part of the same closed loop that kept a city alive. The surface world might become a giant museum. We might see cities preserved beneath ice, roads without cars, and oceans so dark that the horizon disappeared. The stars would look sharper, because daylight would no longer scatter through the atmosphere. But the beauty would come with silence and temperatures that could not support people for long. A new generation might be born without ever seeing a real sunrise. They would learn blue from old photographs. They would learn the word morning from books. They would know that seasons once changed because Earth traveled around one particular star. Still, leaving the sun would not mean that every part of Earth died. The planet would still have oceans, an atmosphere, minerals, and heat from within. If humans built sealed habitats quickly enough, some communities might survive. Small organisms could remain below ground. Life around hydrothermal vents could continue, without caring where the sun was. Perhaps a sunless Earth would teach us the meaning of dependence more clearly. The air we breathe, the food we eat, the water we drink, and the clocks we use are all connected to systems larger than one human life. We often imagine Earth as a solid object separated from the universe. In reality, Earth is an open system, constantly receiving energy from outside. Life grew here because that flow of energy kept arriving. If Earth ever crossed the dark between stars, the things that mattered most would not be a single generator or a single bunker. They would be knowledge, cooperation, and the ability to pass both from one generation to the next. No settlement could survive on a machine alone. Someone would still need to manage water, share food, repair tools, and teach the next group how to keep the system working. Eventually, Earth might travel so far that the sun became only one bright point among thousands. The star would still be there, we would simply be the ones who had moved away. In the darkness, someone inside an underground city might look through a small window and see one unusually bright star. It would be our sun. Its light would still be crossing space, even though Earth was no longer close enough to feel its warmth. Maybe that sight would remind us that home is not defined only by a location on a cosmic map. Home is defined by the living things that care for it. Tonight, Earth is still in its familiar orbit. The sun is still shining. The ocean is still moving under the pull of the moon. But once we understand how delicate those conditions are, we may look at the ordinary world with a different feeling. This blue planet is not just the place where we happen to stand. It is a vast ship, carrying us silently through the darkness of the universe. And as long as we care for that ship, tomorrow still has a sunrise waiting for us. Before we reach the underground cities, it helps to slow the scenario down and look at the orbit more carefully. If the disturbance happened gradually, humanity might have years, or even thousands of years, to watch the orbit change. Seasons would drift away from the calendar. Sunlight would arrive at the wrong angles. Astronomers would see Earth's speed departing from the old models long before the surface became uninhabitable. But a violent stellar encounter would feel completely different. Earth could be pushed away from the region where liquid water remains stable, before humanity had time to build a second home. Those two models tell two different survival stories. The first is a story of preparation. Scientists have time to store seeds, preserve knowledge, and move critical infrastructure underground. The second is a story of immediate choices. Hospitals must decide whether to spend power on heating or on water filtration. Communities must choose whether to keep food in one large storehouse or divide it among many smaller locations, so that one failure does not destroy everything. During the first weeks, the air would not cool at the same rate everywhere. The oceans are enormous. Places near geothermal heat would behave differently from dry land exposed directly to space. Soil could freeze quickly in one region, while a cavern beneath volcanic rock stayed warmer. Clouds might linger for a while, but without solar energy, wind circulation, and the water cycle would gradually change. The difference between day and night would no longer be created by sunlight. It would be shaped by Earth's rotation over a surface that was slowly losing heat. People would stop asking, "What is the weather today?" and start asking, "How many days of heat does this settlement have left?" Time would be measured by energy consumption instead of sunrise and sunset. Over the following years, choosing a place to live would become a major scientific discipline. A city near reliable geothermal power might have a better chance than a city with broad farmland, but no energy to keep its growing chambers warm. Natural caves would be explored not mainly for mystery, but because thick rock is an excellent insulator, and underground water can still move through the planet. Laboratories would become small farms. Crops would be selected for their ability to grow under artificial light. Microbes would be studied for their ability to recycle carbon, nitrogen, and waste back into usable resources. If humanity tried to send a ship toward another planet, the challenge would not be only leaving Earth. The ship would have to carry energy, food, water, and knowledge across a distance too large for easy resupply. A planet that looks close on a map might still take years to reach. And a planet that contains water may not have breathable air, or conditions that human bodies can tolerate. Moving to another world might therefore remain impossible for most people. It could become a mission for a small number of travelers, whose job was to preserve Earth's seeds, records, and memories. Meanwhile, the stars would become the clocks and compasses of the surface. Without a visible sun to define directions and seasons, astronomers would track the brightest stars, measure the shape of the galaxy, and calculate where Earth was moving through space. Children might learn that the sun once served as a lamp, a calendar, and the center of countless human stories. Afterward, the stars would take over parts of those roles. Culture would change as well. Songs about morning and evening would be interpreted differently. Festivals built around seasons would become memorials to the old world. The phrase outdoors might mean a place where protective clothing was required simply to stay warm. But, no matter how advanced the technology became, Earth would still impose limits that no laboratory could completely escape. Every form of power would have to come from somewhere. Fuel would have to be extracted. Minerals would have to be refined. Machines would need repairs. And people with specialized skills would need to teach those skills to the next generation. Survival would not mean defeating the darkness. It would mean managing darkness carefully, efficiently, and patiently. In the long term, Earth might not become a completely empty ball of ice. It could become a planet with a frozen outer shell, deep internal oceans, and networks of small organisms living near hidden sources of energy below the surface. From far away, the planet could look lifeless. The truth might be buried beneath kilometers of ice. That is why our world is valuable. Not because Earth is the largest or brightest planet, but because so many conditions happen to fit together: the distance from the sun, the atmosphere, liquid water, a magnetic environment, geological activity, and billions of years for life to experiment with itself. We may think of an orbit as only a mathematical path. In reality, an orbit is a rhythm that determines how much energy Earth receives, what form its water can take, and whether ecosystems have time to adapt. If that path changed, the greatest danger might not be the cold of the first night. It might be every connected system changing at the same time. That is why caring for Earth today matters, even though a rogue planet event is not a practical near-term threat. We do not need to wait for Earth to become a wanderer before we recognize the value of light, water, air, and community. Eventually, Earth might travel so far that the sun became only one bright point among thousands.